All right, welcome back. Sorry for the short lunch, but I guess we're about 10 minutes past where we committed to start again. So Martin and I discussed the conversation that we had just before lunch and came up with some questions that we hope we'll be better at getting from you. Our intention in this session was to try to get your questions that you would like, not to be, well, you'd love to have the answers now, but that will feed the dialogue that we're going to have. The experts that Sloan has brought here are going to meet starting later this afternoon and through the day tomorrow to try to come up with the kind of research, the kind of activities that could better address your questions. It may be that we'll have time and there'll be some very quick answers, available now, but I'm going to ask our experts to kind of stay in the background for the time being and really ask those of you that consider yourselves practitioners to be the main respondents to the questions we've formulated, and maybe these questions will help. So our first question for you is, in a sense, to get a response which, in essence, for us will be a question, and that is, what do you want to know about microbes in the context of an investigation that you might be involved in as a practitioner? I realize that the term practitioner sort of, there are people who do research and practice, but outside of the context of a project that's funded as a research project, okay? And this is going to vary from country to country, how much of that you do and so on. Anybody want to start this off? Vid?
I'll start.
Hang on, use the microphone, please.
I'll start the conversation.
Wait, it's not on. I'm not sure what the magic is there.
Hello.
Yeah, thank you.
So I guess I want to take it from two levels. One is that we have a IEQ investigation protocol for rating buildings, and we're having difficulty with determining exactly what to specify for as a microbial limit. But the second thing as a investigator...
Okay, so let me rephrase that. So you need to know limits for microbe. So you have species, you have colony-forming units, what do you have that you need limits for?
Okay, so that really gets to the second. When you're investigating a building, first thing you would do is look at total colony units, not look for
This is what you do?
Yes, this is what we do. And based on that bacterial load, you may then drill down as to what's necessary. Is that a reasonable way?
I think the answer to that question has to be informed by how you collected the samples, mm-hmm. and how you analyzed the samples and identified whatever you identified.
Yeah,
so can you tell us that?
It's predominantly airborne.
Pardon?
Predominantly airborne because it's a health risk assessment. And then when you drill down, it can be swabs or water samples or whatever.
So how do you collect your air sample?
The air sample is taken either with an Anderson sampler, is the predominant one.
How many stages?
Single stage.
6?
Single.
Oh, single stage.
Yeah.
So, and what's the cut point, the largest? 500
CFU per cubic meter.
Okay, and then how do you analyze them?
And the prescribed methodology is to do it by culture.
And what do you use to culture them?
I'm not a microbiologist, but
the guidelines, to develop guidelines, these things, yeah. I think. I mean, maybe some of the experts could comment, but I think these things need to be known.
Inhibited media, specifically for either bacteria or for fungal growth. So both of those are necessary.
Any of our experts have enough information for us to talk about that later? How to get to guidelines? Do you have a question for him that will help us discuss that later?
I would just say I would never go for total number here, because what I believe is unacceptable in a building is the gross. So you have gross of molds in that building, and then if you don't sample the right place, then you may have a lower number of that, and it will always be obscured by the normal background in the building. So
Let me know if
I would more look for something suspicious there. So total would rarely give us anything, but you really have to pick out which ones it is, and are you having 500 of exactly the same, or are they 500 different microbes?
The strictures put on the first layer of investigation are cost and time. The second layer is the investigation layer if there's a problem. So in terms of cost and time, do we need to go into a full house investigation and rip out the ceiling tiles and so on to get a rating system going?
Well, okay, so I don't want to let this conversation go on too long, but I think you've made a point which I'm aware of, which is that cost and time are relevant for practitioners. And I once was part of a 3-part day-long course for industrial hygienists here, and the guy who did the mold part described something pretty blunt, not detailed, and one of the students in the class asked him, well, don't you have to, do more detail? And he said, well, yeah, you should, but nobody's going to pay you to do that. So can we turn that into a question for the experts? Is there something cheaper than what he's described that can be done that would be more useful? And so can you record that as a question? Somebody else have a... What?
I have like 2 questions. I don't know if you have answers for them. But firstly, I would like to know, what kind of amounts of microbials can be transported in an airflow. And the other thing would be interesting to know that what kind of amounts of the microbials can cause health effects.
Well, I mean, if you're talking about something very virulent, like tuberculosis, 1 bacterium is too much. And then there are other things where you need more. But so again, I think specificity is required to answer your question. What are you worried about?
No, it's just I'm an engineer and I'm investigating the buildings and doing the decisions whether to renovate or not. And these are the things that are interesting for us.
Okay, so,
Yeah.
and you were hired by the owner to investigate it, to determine whether to renovate?
Yes, for example.
Uh-huh.
Yes. Like cities or private building owners.
Oh, so this is sort of
This is like a common
a theoretical question.
Yes, because we have the problem with the air leakages, that the joints of the structures are not airtight. There are the leakages, and with the airflow, the microbial impurities are entering the indoor air, but we don't know what kind of amounts do enter with the airflow, and we don't know what kind of amounts of microbial impurities cause the health effects. Actually, we don't know what kind of amounts we can allow to have.
Okay, so I'm going to ask our experts who are meeting later, when you hear these questions, if you have some questions that you want to ask the questioner that will help us have a question that we can discuss in terms of the science, please do feel free to do that. Jordan?
Could I ask a question of the questioners? Yeah.
Yes, please.
So when you're investigating a building where there is a complaint, do you care what the microbial measurements are? Do you care about speciation? Do you care about total number? What are the things that you care about? And if you don't, if you only care about the species because they tell you there's a moisture problem, why even measure them at all anyway? Why not just go look for moisture?
Well, I always, when I do the investigations, I look for the complete entirety. And first we investigate everything else. We measure the moisture, open the structures, and if we can solve the problems with these things, then we take in the end the samples. And well, for me, it's maybe the quantities is interesting. Sometimes specific species also they give some information into what direction to look for.
So does the building smell moldy?
Yeah, and
Is there a smell of mold in the air?
yeah, for example.
Oh, there is?
Yes.
Okay. Is it an air-conditioned building?
Sorry, which building are we talking about?
Does it have air conditioning? Does it have cooling?
Well,
she's talking about she's doing multiple investigations on daily basis in different buildings and different types
Yes.
of things that she
Yes.
needs to know.
Okay, why don't you send her your dissertation? No, I'm serious because I love Uva's dissertation. Anyway.
She comes from the same school, so.
So I asked about air conditioning because I go into buildings that the drip pan from the air conditioner's got a whole lot of slime in it, and the way they've handled it is instead of trying to find why that's happening, they just put some biocide in there, you know? I'm sure they do that in the hospital, right, Jack?
So I have a very specific question. So I'm a microbial ecologist in a building environment, but I don't know what metrics someone would use to determine if a treatment to a particular fungal problem or moisture problem had been successful. So do you have a particular metric by which you determine success of a treatment in a hospital? I mean, in a building?
I need to take the mic.
I mean, it's a room full of experts in this area, so I don't know that. That question.
you mean after renovating something that how do we prove it that it was renovated okay, that now it's okay?
Yeah, someone says, my building sucks, there's a real problem here.
Yeah.
You come in and go, yeah, your building sucks and this is what you should do. How do you determine if your intervention was successful?
Well, firstly the user is the best one to give the feedback.
So they say, it doesn't smell bad anymore, it's all good, thank you. It's
No.
money.
Okay. After renovation.
So,
Really?
unfortunately,
Is that
well, tell us what
No,
what
I have
methods do
some.
we have? We all know that we
Wait a
have
second,
them.
Mia?
I'm sorry, I can't be quiet anymore. So I thought that, okay, in between you and you, we need a god or some sort of ball that tells the truth that we don't have, about the exposing agents that are the mystical part of the entity. So we don't know what to measure. If we don't know what to measure in the beginning to evaluate the problem, well, how could we know what to measure in the end? So what we do is that we technically find the problematics sites on the structures, the risk structures and the moisture damage structures, do something to them, and then we suppose that they were the source of the problem, and we did something and we hope for the best, so to say. Of course, real buildings are tricky. We never can be sure that we found everything because we can never make it into this cheese with drilled holes, or if we do so, well, after that we can be sure, but it's not relevant. Yeah.
Case study.
Case. You don't need a mic.
And can pick me up.
Yeah.
Can you give me a case study? I want to get a specific case study, just like a 30-second, minute-long case study.
Okay, what would it be? Well, one.
I'm betraying my ignorance. I'm betraying my ignorance totally.
Yeah.
I'm not attacking anyone. I just need to understand it better.
Well, for example, a big office building with smells and health complaints, and well, we didn't measure microbes in the air because there were health complaints and smells, which are enough to show that it's about microbial problems and about the structures. So we start with this surface moisture screening to find like acutely wet sites, and we find something. We found areas in the floors beside the external walls and the like this base structures which transferred moisture towards the indoor surfaces. We found something. Okay, then we didn't have the blueprints. We maybe made drill holes to find what sort of ground-facing structure we have. In addition to having something on the surface, we found that there was this double slab, two concrete slabs and something in between, and it was organic perhaps. And then we found something from there, and then we have to decide, do we dig it out, which is very, very heavy. You have 10 centimeters of concrete for hundreds of square meters, and that's heavy renovation. Or can we block it? Can you answer that? Can we block? We should know, what are we trying to block? Is it gas, semi-volatile, particles? These are the questions I need and Katarina needs in our practical work. We just put it into 30 seconds. Yeah. So that's a like very typical case to like tear it down or try to block it. We usually, if it's like really rotten, we tear it off everything and clean it. If it's just local, we try to block it. We maybe under-pressurize the organic layer there. If we don't have to make it work for 30 years. If we have to make it work for 30 years, we tear it off. More or less it goes. So, but we have alternatives. But it would be of great aid if we could measure it, like what's the bad thing in there, or at least if we would to some could be sure if it's how does the bad thing behave most like probably. If it's a gas, do we have to be worried about diffusion through the slab, or is it just convection, or what can it be? So these are the practical questions. Yeah, but after doing something, we observe for the smells. Of course, we can do air sampling, and we hope that the people who come to the building won't get asthma. We can't hope that the ones who got the asthma would get healthy, because they won't, even if the exposure stops. But that's how it goes, more or less.
You know, one of the points that one of the points that I have two microphones and none don't know how to work them. One of the points somebody made is the building sucks, right? So you know, I think Mia emphasized and someone else here emphasized that you need to know about pressure differences. All buildings blow or suck. The question is where and when. And most, to be in balance, have to be doing an equal amount of both at the same time. So anyway.
We were talking a lot about microbes on surfaces and internal structures. This is a risk, but what turns the risk into exposure? I mean, the microbes have to reach my airways in order to create a problem. So what are the environmental situations which make it probable that the microbes, fungus, bacteria, reach my airways? So pressure difference seems to be very important, but what about temperature? What about humidity? When I understand this gentleman right, it needs water in order to grow mold. But what is more dangerous is if the mold is there when the air is dry, because the mold transports easier into my airways. And what I'm not interested in the risk, I'm interested in the exposure, because the exposure makes me sick.
But your exposure might not just be from your exposure might not just be from a microorganism. It might be from the as you said, the volatiles or the small volatiles, large volatiles, whatever that's coming off. It's the chemical exposure that's a key component. So if I was to say I could give you set limits for volatile organic compound concentrations in the atmosphere, and specific signatures which are indicative of that smell response for people. You're smelling this because this is a chemical that's being released, and I could tell you which organisms are generating that and which fungicide or which microbial bioactive aside to actually add to that situation to ameliorate that particular compound. That would be effective. No, that wouldn't be effective. No.
No. So some of the smelliest compounds are not known to cause health problems.
For years, you can take a piece of furniture that's been close to mold and it will smell 5 years later.
That's true.
And that's the physics of diffusion in materials.
Okay. Like, very stupid question. If you can... Yeah. I have a stupid question. I don't know if you can answer. Why does moist material smell?
There could be water-soluble chemicals. There could be water-soluble chemicals that are dissolved in the water and that are vaporizing. There could be mold growth. A lot of problems in Sweden, you're probably aware, are caused by moist concrete, and then they put the flooring in and alcohols are formed, for example. And, I like to go to a place where the alcohol content in the air is very hot from very good Belgian beer and a proper sniffer.
So I have a question concerning metabolomics, because now we're close to the metabolomics. So all the methods that comes after metagenomics, maybe. Jack Gilbert, maybe I've heard you have a project about that. So how we can determine what microbes actually doing, what they are emitting, how they can interact via metabolomics with other microbes, and where are the limitations, so like the biomass or so, that we can use these methods in the future.
Run. I've forgotten the question you took. So as I was saying for this, if we understood that there was a particular metabolite profile for an environment, we can predict what microorganisms are capable of generating that metabolite profile by taking the genome of those organisms and predicting their metabolic potential. That's only based on annotatable functions, and so there's a lot of, that's the limitation, there's a lot of black unknown space in the genome and a lot of black unknown space in the metabolome. But we can definitely link functional metabolic output from an organism to the metabolite profile we observe in an environment. And so...
Not on secondary metabolites, not in fungi.
No, we can. That's technically possible. We've done it. In soils and in plants, we've done it.
So how are you sampling?
Because the polyketide syntheses are circular, you can't predict the product of them yet.
No, but for certain secondary metabolites associated with plant microbe relationships with a fungal, bacterial, plant precursor, you are possible. I'm not saying for all secondary metabolites, of course. And I just said there's blackness in the genome and there's blackness in the metabolome, things we can't predict, things we can't annotate. But it is technically possible.
We have in the building, so.
Okay, so in that case, it's.
We work with that with full genomes. We look at the annotation of genes, and it's so complicated.
Yeah, but it doesn't mean it's impossible. No, complicated isn't impossible, and you can do it. And every time we get a new genome, and every time we get a new metabolite profile, and every time we can predict a new peak, we get a little bit closer to being able to annotate it. Just because it's difficult or complicated doesn't mean it's impossible.
But are you measuring the MVOCs in the air?
Yeah.
You are? How?
I know you got to ask Brent about that. So we have an MSMS spectral nose that we use for detecting VOCs associated with surfaces and with soils.
And you're able to identify the MVOCs.
So working with Peter Dorrestein out at UCSD with his peak detection software, which utilises comparative analysis from samples across the world, across different environments and soils and in built environments, in human gut samples, in marine environments. Yeah, you're able to do peak identification at very high specificity and annotate sometimes 20 to 30% of the peaks which you couldn't annotate previously with comparison to existing databases. We're actually able to increase our annotation capability.
But with an air sample that's practical to collect in an occupied building?
I'm an academic, not a practitioner.
Well, because I asked Charlie Wessler that question and he said no, and he's in contact with Peter about it. So, I mean, there's this wonderful database of MVOCs.
Yeah.
And so I thought, you know, if we could sample those, then
Well, yeah, we're nowhere near practicality yet, but the point is we're moving in that direction.
Okay.
With stuff that could be useful in the future.
Okay.
Maybe I'm just too optimistic.
Are you responding to that subject?
No. She's one of our experts, so you're ahead of her because of that.
I'd like to go back to the amount of microorganisms in the air. And I'd like to put a case beforehand to explain.
Like
to explain it by a case in a real building. And I'm an occupational hygienist, and what I do is measure microorganisms in the air only for political reasons. When I go to a building, like a building I had where the mouses are running on the desks behind the air conditioner in the rooms, and people are saying, well, the mouses are climbing on our trousers and peeing on the desk. And also the air handling unit is very dirty. Then I say clean. But then management says, well, I don't see anything. And in that type of cases, I think it is very necessary it can be necessary to measure microorganisms in the air. And in the Netherlands, you have an organization of people that measure microorganisms in the air, all commercial consulting firms. And they put standards, and they put very low standards. And the questions I have, are there really anything known about the level of health complaints for certain microorganisms in the air? And I gave Hal a list of where I thought about the gram-positive bacteria, gram-negative bacteria, non-pathogenic molds, and the levels in the air. And I wonder if anything is known about that really, because when I look in the literature, I don't find anything.
The response of people to different levels of microbes in the air is very personal, so we don't have it. But what you can do practically is to go and find the source of damage if you have one.
Yeah, that's what, the source was very visible, and there were some people that were very sensitive and had health problems and couldn't even go to the workplace. And after everything was cleaned, because I said there were too much microorganisms in the air, and I did more or less, because political reasons. I had to convince the management, and the management had to convince other people to give money to cleaning the floor and everything, and the air handling unit. And after everything was cleaned, also the people that had no complaints said, oh, it smells much nicer here, including the management.
Human beings.
I think the rules should be changed in this case. You mean that politicians make you take air samples to document that a building is healthy?
Well, the management, I mean political sense in a very big organization like a university. They're all political mechanisms. So the management needed to have figures to give them to the people that supply the money.
So starting at 4 o'clock this afternoon until 3 o'clock tomorrow afternoon, I have all of the experts locked in a room to discuss the science and the responses to all this. So we really want to know the questions, and I think we got the question.
Thank you. I'm slightly biased because I used to be a mycologist, but since then I've done a lot of consultancy work and I do a little research on the side as well, so I have a bias there as well. But for consultancy work with clients, they want to know about risks. That's quite clear. And they want to know about solutions, and the solutions are not going to be provided by the microbiologists. It's about the building maintenance and building physics and ventilation, and that's where the solutions are going to be. So until you will provide us with some risks connected to microbial exposure, which I think is very meager for normal indoor environments. It's plentiful for work environments where you handle really large concentration of molds. But then, until then, I think we need from the microbiologists ecological function of what we find in our samples. What can they do? Is this going to grow on relatively dry materials? Is it going to, like my drywall or my paint, will it really grow below 80% relative humidity or equilibrium humidity? That kind of thing. Ecological function. What is it going to do? Where is it going to work? What is it going to produce? What metabolites, please, if I can have that. But I know that this is, again, connected on the substrate it grows on.
Yeah. Okay, so both Christian Nielsen and Jeff Siegel talked about kind of a threshold in terms of moisture for growth. But the best reference I know for it says that it's species dependent. So there isn't one magic number, 80%. Or 85% or 90%, and it's from Olaf Adam, who's based here at the University of Eindhoven. And other than that, I don't know, does anybody know any other reference source that's species?
Yes, there is a lot on foodborne species from along.
Those can be, material is more difficult and less susceptible. I mean, it's difficult food for them, but they grow.
Yeah. Okay. So you had a question over here.
No, well, I actually wanted to come back to the question that was raised. Why? Well, the question: do you need to measure? And I think that is something not really discussed. It has been put up again, like, okay, I measure because I need it to convince people to take action. But then I think the real question is, again, on what level should you set your standards for? And to me, as an epidemiologist, I would like to have standards that are health-driven. And if you think about the changes, so for cultural, there are some guidelines which are, to me, as far as I know, not based on any health-based evidence either. So what should we do with the markers that we can measure right now by qPCR? And should we go through this process of defining health-based guidelines measures, or should we think about other things? Can we just discriminate buildings that are problematic or not? And is that the real question that we should go for?
We could lock a group of toxicologists in a room for 24 hours and they won't come to agreement either. Right now, in Europe, the standard for formaldehyde is 100 ppb, and in California, it's 7. and the US EPA is moving toward the 7. So, and is based on different assumptions. And I suspect that the same thing will happen as we get more information about some of the exposures from microbes, but I don't know.
So a question again to the practitioners, more specifically about the last comment, which I think is a good one. When you go into a building because there's a health complaint, what does that health complaint look like? Is it always completely varied? Is it often ambiguous? Does it fit into some certain categories? For example, is it my asthma is more severe in this building, or is it I just don't feel well in this building? Are there certain types of categories, at least, that you can put those health symptoms that you address into?
Sure wish we had a different kind of arrangement. It's all about the building.
Apart from the complaints about too hot and too cold and too drafty, the health complaints are mostly the type of irritating from eyes or throats or lungs or that type of thing, and sometimes headaches and being too tired. But I find that when I have a survey that 20% of the people always have headaches and 20% of the people are always tired. So then that leaves the things of irritation from eyes, nose, ears, more often having a flu.
Somebody have a different answer to that? Or a different? Yeah. Okay.
So I have two questions that have kind of been hinted at by others, but I want to ask them explicitly. If we had a magical device that could measure whether a moisture problem exists in a building or not, what's the sense of the room on two aspects of that? One, would that correct any problems associated with microbiology if we were able to fix and correct those moisture problems? And two, what would the perception of people who owned or operated those buildings be? Would they accept that as, would they accept not doing any biological sampling? That is to say, do people want to see biological sampling because there's a perception piece that's really important that, well, you need to be measuring something for us to be able to do something, for us to feel good that something has been addressed. Because we find in a lot of other aspects of indoor air quality that a lot of what you're doing is managing the perception of the building owner or occupant. And sometimes, I guess I'm asking the question, is that what one of the functions that biological sampling serves?
So I know UVA has dealt with water a lot, so.
I just actually wanted to comment on the health-related questions that we at least currently recommend that the building investigators do not attempt to make any health assessment unless they have a medical background. So that's from the practical point of view. But then I also wanted to ask, just out of curiosity, is that it seems like here we are focused more on dampness-related issues in buildings, but could we also use these molecular methods to evaluate other types of issues like hygiene or spread of infectious disease and things like that in buildings?
I guess to some extent, yes. You can also, with molecular methods, you can also target violence factors, but you will not know if they're actually active. But a microbe that has a virulence factor has the potential to infect a person, for bacteria, for example. So I think it's not a final answer to use a molecular method, but it will help for sure.
I wanted to ask the practitioners about resilience, how much you work with it when you make a building or renovate a building, in the sense of should a pipe break, how will you fix it? Or in the sense of if there's a 100-year flood, which happened in New York City, and most of the damage that happened to housing after it was through sewage and water that got into the buildings. And then I found Maria's point very telling when I said the mold that they got afterwards. She said probably the spores were there originally, not carried in by the water or sewage. And so I wanted to ask if the practitioners consider that, and if there's possible room for collaboration in asking about making the original structures resilient, or changing the construction practice, even though you don't have a microbial problem, how to either prevent it from arising as easily or make it more easily repairable, detectable, that kind of thing.
There is a trend in the design community to specify more water resistant, or materials that are less likely to support mold growth and to tolerate moisture as far as the material deterioration goes. But maybe someone else would like to answer that. My experience, and my background's architecture, and I've consulted on the design of a lot of new buildings, is that the architects like to assume that everything will be perfect when the building is completed and the occupants move in, and anything that happens after that is the occupant's fault, right?
It would be fascinating in that situation, and we saw the same thing after Katrina in New Orleans. It'd be fascinating to be able to determine if any of the homes that were already impregnated with the fungal spores that didn't show significant growth, because there were homes out there that didn't show significant growth, whether they were contaminated beforehand and whether there was something inhibiting the growth or the germination. That would be, and if you could commercialize it.
It's the question of prophylactic probiotics, and that's what it's a question.
Yeah, I'm really excited about that. I know you're cynical, and I know a lot of people are cynical.
Talking about mold problems, we should know the properties of building materials, of how many building materials we know, how they wet, how they dry, what is their hysteresis, time of wetness. Unless we can't answer these questions, which we can answer from a tomato, but not from bricks, we won't find any good solutions.
Fundamental knowledge gap. There is a huge knowledge gap in this area.
There are tests for testing new material in terms of whether it will support mold, and I was at a presentation 3 weeks ago where someone showed that all of the tests failed. I mean, several standardized tests that are used in the US that simply don't work.
I just want to comment on the materials part and on the building structural part. In this part of Western Europe, we have a very big tradition in testing all of the moisture capacitance and moisture reaction kind of behavior of but it's all in the building physics departments, not that really in the HVAC departments of academics that they are studied. But the knowledge exists and is very rich. It's just a matter of connecting to it, I think.
For those of you who were in indoor air last year, I'm repeating myself, but we have plenty of information, at least, well, nationally we have, it's building physics. So it's there, and the science of building physics is largely about microbiology. It's about preventing mold growth in buildings. And the limits, the building physical limits that are acceptable in the performance of the structure are based on microbiology, on the mold growth. So that's how the buildings are supposed to be designed today. Yeah, of course, lots happens in between the blueprints and the building when it's ready. So it doesn't happen as the architect thinks when they start constructing the things. But there is information, and the parameters they have been defined. At least I'm pretty happy with the information that I can find from the Finnish literature or the German literature, which has been translated to be used by the Finnish engineers. So I don't recognize that kind of gap. Of course, we have new materials and like within a product category, there are huge differences between like drywall and another drywall, or like chipboard and another chipboard, and all they should be tested, and we shouldn't be always know, but what we are dealing with, what kind of product is it, but there is the basic things are available, I think.
What about context-specific activity? So, I mean, if you're in different bioclimatic regions or continents, if you're in different cities.
I have no clue.
I mean, so that's where the knowledge gap I was pointing to comes from. In understanding the biological activity and in context-specific situations. In the lab, things behave a certain way, and that's what buildings are designed on for the most part. And 150 years of experience, but there's always context-specific things which seem to be the outliers. It doesn't behave the way we expect it to behave.
What do you mean by context in this context?
You weren't here, Jack, when Jeff made his presentation and he showed 3 materials in 3 offices in each of 3 cities, and there was absolutely no similarity between Flagstaff and San Diego, for example.
And not only that, those are exactly the same
materials. And they're samples from the same
But we can model.
Yeah.
What?
What? I must be honest. No, I mean we can model moisture.
No, but the specific answer to the question about the level of knowledge about materials and the comment that it's context specific, I was just trying to say that I think he demonstrated that.
Yeah, I think that there's huge threat that we are talking about completely different things and completely different structures, that our views are so different that we just, keep on well, not solving anything, but it's just a huge mess. But anyway, of course, when, for example, that the materials are different locally, or the structures are different locally, and the climate is so different, like around across the globe. So we should really, for example, when we publish something, really define where does this case, where is it located, and always the geography tells a lot, and also define much better the materials and the conditions that are related to the issue that we are talking about.
That's essential.
And I didn't mean to say that there wasn't information about this. I'm fully aware. I work with building scientists. I'm not, and I've only been in this area for like 3 years, right? So I know nothing about it. I'm totally ignorant, comprehensively ignorant.
You are progressing. I think last year you said that I'm not interested in buildings. So that's
Yay! I've got better. Did I say that? Wow.
not to me.
No, I didn't say it to Paula because I wouldn't get funded. Yeah. I mean, it's. I've been noticing that things don't work out the way they're supposed to work out in different situations. And in the hospital that we work in, for example, different fungal spores react differently on different floors and in different rooms. So on the same material in different parts of the building. And we think that's due to microclimate, like you were saying, right? Microclimate is very important. But yeah, but it's also what's there to colonize that space.
Can I keep this?
I have a few remarks.
You have to use the terms properly. When you say colonizing the space, do you mean active colonization, or do you mean that air currents carry the spores from rooms to rooms?
No, I mean organisms which arrive in that space and can actively divide and grow.
In the space, in the air?
No, on the surfaces after deposition and suspended material.
On wet surfaces, you mean?
Above
75% equilibrium relative humidity.
And we've seen it with surfaces which have reasonably high relative humidity, or surface humidity, is it what you call it? The stuff that Brent tells me.
Equilibrium relative.
Equilibrium.
That one.
I like that one.
So we see that on certain materials, things are actively dividing, and so I call that colonization. The thing it can survive and divide and grow on a surface.
And that we are talking about over 75% equilibrium relative humidity. Under that, unless somebody demonstrated, there is no microbial growth.
Okay.
That is,
Can I
we've known that for 300 years.
Okay, so
Don't throw this knowledge away.
I didn't criticise that at all. So I'm not even remotely criticising.
Yeah, but don't say there are gaps of knowledge. Maybe you don't know, but you know, if you've been.
I didn't mean that. I didn't mean there are gaps of knowledge in this area. What I meant is there are gaps of knowledge in the mechanisms which underlie microbial metabolic activity on these surfaces.
Don't go so deep, but we have time to discuss.
Yeah.
Okay. I don't want to be a pariah here. I'm not trying to be a pariah. I'm just coming at this from a different
Actually, I had a slide for you, Jack. In my presentation, you weren't there, and I skipped the slide anyway because I would have overdone it badly. But I had a slide with these alternative terms. One was community versus dirt, and developed community or biofilm versus old dirt. And I'm really worried because we have papers who talk about communities where microbes are interacting with each other and talking about surfaces where the relative humidity is like the time of wetness doesn't really exist, and apart from some corners with cool like microclimate and maybe relative humidity towards 75 perhaps occasionally, mostly these surfaces are below 55 and anyway most of the time below 60. So if of course these, you can say that some species are active, but activity is quite relative. If it can like double in 2 weeks, okay, it's growing there and it's interacting with something, but it's extremely slow. And compared to that kind of activity, the incoming dirt over it's like 100 times, 1,000 times more like important in terms of biomass and in terms of presence anyway. So like as they put it, like surfaces are sinks. They are not producing much unless there is something very curious going on.
You two are going to be able to talk to each other all day, so we want to learn from...
I agree with you 100%. Hold on. And I don't think I've ever argued that point in the opposite direction. Well, not
I wonder if the survey would be a good way to get some useful information.
I wanted to ask something of the practitioners in terms of, they said, what are objective measures or something, and to emphasize that the objective measures, and then Maria's point that people differ in sensitivity a lot, because, of course, when you're dealing with allergic, immunological, sensitive issues for a particular antigen, you probably have easily a million-fold variation in individual sensitivity. So there has to be some kind of question about, you want to, protect 99% of the people. I personally think you certainly should want to, and that the sensitive people, the people with asthma, there was one thing, for instance, we saw a study of in China where the person was asking if you filter particulate matter, are they healthier? And nobody really became healthier. But when asked afterward, they only took very healthy people in the study to begin with, and so it's very heterogeneous. And we haven't talked about human variation and human sensitivity and screening for allergies among the people who are in the building. It may not be appropriate, you say, well, 10% of the people always have a headache anyway, so we can't, but indeed there may be huge sensitivities, and I'm not sure how to deal with it either.
She hasn't told us she's a mycologist yet, or that she wasn't. So I went to her first.
No, but actually I am a mycologist. I work at Danish Technological Institute, and we're a group of building surveyors, practitioners. And a couple of years ago, we made an analysis of what are people asking us when they phone us. And 75% of people calling us are talking about health problems. Not allergy and asthma necessarily, but those symptoms that I've headache, I'm tired since I have moved into this house. Then we start asking them about what are their buildings, age of the building, construction, etc. And we find out, shall we go out and make a survey? And in 50% of the cases where we came out and did a building survey, there were huge mold growth hidden in the constructions. We are not doctors, so we don't make any comparison with the sickness of the building and the sickness of the persons, but in 50% of the cases, the mold was hidden.
Right, so the most perceptive people really are getting.
Yeah, very important.
If I may, on the practicalities, when we have kind of sick building awareness, something like that, complaints, it's not a viable way to try to establish a level of contamination or pollution that is guaranteed not to harm anybody. So we don't go there. We go to the WHO report on moisture and health and say that, well, moisture damage isn't healthy for you, so we will remediate that, and then we might try to relate what they have in the building with more everyday references, context. Okay, you have a little cladosporium on your windowsill. You also have 10 times more of that on the bush on the outside of the window. A little bit of that kind of information is often useful. But that is not to say that we do not prescribe a thorough renovation of the moisture damage and the removal of the materials, and perhaps even an air sample to document that we do not have elevated levels of species that are connected with those damages that we find. But of course we also know that when people learn that they will have symptoms when they go into a building or feel the smell of that building, they will repeat those symptoms even if the cause of the symptoms are gone. So they tell them that as well, and they really like it.
I think that we all are caught in a trap. Most people in here, they're afraid of humidity because they say humidity causes mold. But we are all human beings and we need humidity. And if we start fighting against mold by reducing air humidity, which is not really is interconnected with a mold building, because that has to do with the water activity more than with the humidity we can measure in the air. So what we do in wintertime in our temperate climates by reducing the humidity makes the situation much worse, because that's a question of aerosols, the way the risk comes into my airways. I speak again of that. That happens by aerosols, and the physics of aerosols tell us that the risk goes up when we have dry air.
I have a more general comment, and I'll keep up the flag here for Aino Nevalainen, who used this quote many times. There is a quote from Tolstoy saying that unhappy families, happy families are all happy families are all alike, unhappy families are unhappy in their own way. And she always sort of referred this to buildings. I think one complication in many aspects that we're discussing here is that we're trying to categorize things into a system of buildings which are so diverse, and no moisture damage is the same, no exposure situation is the same. So we're trying to, squeeze this into things that fit our views, but it's not really happening.
So this is just a really quick point, and I'm trying to find a better source than what I'm going to cite for it right now. But I'm obviously not a microbiologist, but I've tried to be somewhat well read on the association between water activity and fungi, and I would argue that there is evidence of fungal growth below a defined 0.75, for example. I'm looking at some work from Olaf Adam that shows, it's not a large number. Certainly the majority is happening below 0.75, but there are many species that can grow down to 0.65, in some cases even down to 0.6.
Can you mention the names of the species?
That's what I'm trying to find specifically. I just have a histogram of the number of species.
Bulimia is one of them. Down to 16, 70%, yeah. There are very few cases, and it grows in the building, and we know it.
Yeah, they may need more moisture.
Yeah, and then there's also this question in my mind that comes from a building science perspective, in that things are so dynamic and so changing in a building that I wonder if there is, we're missing water activity that's relevant above a threshold simply because of what we're able to measure and how we measure it. So that is materials staying wet, but not in a way that we're able to measure or able to see that, especially in interstitial spaces or places that aren't immediately easy and obvious to measure.
Yeah, when these things get documented, I will believe it. But for the time being, I'm holding to the known science. Sorry, I'm a scientist.
Yeah, okay. I suggest, unfortunately it's in Dutch, but Olaf Adam's PhD thesis.
It's mainly in English as far as I recall.
I've only seen it in Dutch, but that's fine. Might be in English.
Pretty sure
I'm not arguing
I would say that this is by no means like conflicting to what I and Maria said, because now we're talking about thinking of practical perspective from Finnish conditions. We have this, for example, this very common structure, very common risky structure in small houses where there's like a slab on ground without no thermal insulation below the slab. But above the slab we have wood and wood chip insulation. And if there is any wicking moisture from below, there is usually a moisture blocking barrier, some bitumen or something, but it ages and then it finally lets the moisture come through. And there we have two phenomena. One is the wicking moisture from below, and it's often it's minor, so it's not completely wet. And in that kind of structures, we often have this 70, 75-ish, and it's also quite cool below the thermal insulation, which when it's cool, of course, lesser amount of water creates higher humidity or relative humidity, and then we get some kind of boundary conditions for mold growth, and we often see it when in a place where we can quite reliably say that this has not been much above 75 or 70, and given the 3 decades, we have mold growth there. Of course, I want to know what is the significance of that, because it has been very low, and we know from the mycotoxin studies, or we assume that not much production of mycotoxins is happening in such low relative humidity. We are not sure about that. And of course, we're never sure about the history. We have no clue, to be honest, what it was what kind of year did we have, like 1989? Was there something exceptional that created something really weird into that structure? In practice, we have the history always when we go to a real building, and we never know what has happened there. So it's kind of a bit stupid to be very strict about the humidities and so, because we never know what it was. Yeah. But well, if there are symptoms, people are feeling bad. Of course, in majority of cases, it seems that the massive amount of wood chips is absorbing much of the impurities, the volatiles, so that you really have to dig it. If you do something with the structure, then you get problems. If you just leave it there, stay quiet as it was, it's okay. But a new family, for example, moves in and they want to switch the old boards on the floor or something, you might get some problems, and they install maybe some ventilation machine which makes everything go differently, so that problems occur. But these are like practical situations. I would like to have more information about how should we address these kind of entities. Yeah. I don't know.
Just to throw in a bit sort of more complications in this water activity material thing. A fungal spore is much more demanding when it comes to water activity than a fungus that has germinated and that has passed a certain stage. Then it can actually tolerate drying out, and then it can sit there and it can become dormant or go into hibernation, waiting for sort of the next flood, and then it will take it 1 or 2 days. It has resumed growth and it grows just as fast. But in the meantime, it just sits there and do nothing. It's not dead, it's just waiting. So we have germination, water activity, and we have growth, water activity. Two very different things.
We've seen the same thing with Staphylococcus on surfaces in the kitchen. So the periodic wetting of people washing their surfaces on the kitchen counter, you get this. You get nothing. There's sporulation, and then suddenly there's germination, and then the growth just goes through episodic events, and it builds up. So you get a biomass increase over time due to episodic wetting, drying, and it just keeps on increasing until it reaches a threshold level where you can actually have somebody come along, touch the surface, and pick up a load which allows that to then colonize their nasal passage or oral space.
Yeah. I have a question for the practitioners, which comes from asking what all this metagenomics is for, in a way, because most of the diversity is very rare. But and that we're focusing, of course, for the practitioners on those things that are harmful to many people. But even though we're used to saying that the microbial diversity, say, including in our gut and everything, is 100 times more the diversity of our genome, I don't think that's correct when the immune system is taken into account, actually, because we're generating a lot of new sequences, and the possibility is very real in my mind as I'm sitting here, that one person is incredibly ill, for real, in a building due to some rare microbe, not the ones we're looking at now, but they're truly ill, the same way that 1% of the people can't tolerate gluten, or some occasional person is deathly ill to peanuts. That kind of millionfold difference is totally possible in terms of immune reaction with the microbial world, in theory. I want to know. And of course, it's very difficult because somebody calls you up and says it, and the people will say, well, can we give you some sedative, some Prozac, some therapy, because thing. But in fact, the individual difference, it might be a case, for instance, I'm thinking of screening the immunoglobulins, that this kind of, a missing part of the phenomics is the immunophenomics. And I'm thinking about how to develop that. I have schemes, but I'm wondering if you see the other end of it. People you would dismiss as being chased by UFOs, but in fact it may be very real.
Can I say something as a practitioner? Because it's a very real situation when you have a single person in a building that reports really building-related symptoms that are severe, and we often give the information that yes, we can remediate this building so it's as good as any other building, but we cannot assure that there is nothing specific that you are very, very sensitive to, and that we can remove all exposures that are relevant to you as an individual. I think that wouldn't be fair. If you still have some symptoms, then you're mad. No, we don't say that.
Yeah, I just want to say, you know, some of you want to be able to get over to the closing ceremony on time, so we'll stop in about 5 minutes. And so, again, the goal of this session was to get the questions that the scientists can discuss. And while I think the recent discussion is very relevant and important, it's not something that the expertise exists for here. We're really talking about how to apply the molecular methods to better understand the indoor microbiome. I think we all agree that it's important because of health impacts, but we don't have the expertise here to make the leap from understanding it to interpreting it. And maybe that's something that needs to happen first in order for us to know what we need to characterize in the environment. And I think the point about individual variation has been shown equally to be true about chemicals.
I have one example of a person that was specifically ill for something, and then I have another question to think about later. The person was very allergic for Aspergillus fumigatus, and that is something that is really in the earth, so not very rare specimen. But she was afraid to come back to the building. She wanted to know if there was any Aspergillus fumigatus. So we measured, and we found one, I believe, and she was able to go back to work. And the question I have for the conference, what is behind this conference, is in the Netherlands there is an organization that's called BioOrg, and that has a sort of probiotics, like you can eat for your stomach, for probiotics for the buildings. So they spray it around, and then they say, well, in air-conditioned buildings, then you keep out a lot of outdoor bacteria and maybe also other bacteria and molds. So if you have problems, that is from bacteria and molds that are that can spread because they are not controlled by the normal good bacteria and molds. So they spread the normal good bacteria and maybe also molds. So I don't know if it's somewhere else also done, and I'm wondering what experts are thinking about this method.
It sounds funny, but so we've identified a bacteria. We've identified a bacteria which can control fungal growth in showers. So we've been playing around with this, and we spray this particular bacteria, which comes from people's stool. So it's a human gut bacteria, but it's an aerobic. It can survive and grow in an aerobic environment. If we spray it on the inside of shower spaces, it eradicates mold growth in the interstitial spaces between tiles, and we can check that with qPCR. So these things are real. You know, bacteria actively produce metabolites which can control fungal germination. And we see this in the gut all the time. If you have Enterobacter, you're going to get sick. If you have Candida, you're going to get sick. If you have Enterobacter and Candida together, you don't get sick. They both enter into a commensal dormancy state. They actually they suppress each other's virulent activity, and we see a similar thing in indoor spaces now. So I think it's a real thing.
Just one comment on the recent comment. Legionella pneumophila comes from the soil. It's everywhere.
So I want to come back to my initial question.
We've got 1 minute.
I know. And we have a post-occupancy rating system which includes microbial measurement. Because of the fluid state of knowledge, we're thinking of taking it out. Should we do that or not? In terms of screening buildings, not talking about the problem buildings you're talking about, it's a rating system. Should we leave it in or should we take it out? And what should we be measuring?
Well, I would ask the same questions I asked at your first one, which is how is it measured for purposes of the rating system?
Well, currently I'm saying, I've described that, that's an airborne measurement. I'm saying, should we not measure microbial activity in a building for screening purposes of post-occupancy rating until such a time as there's a consensus?
All right, so I'm going to wrap it up now and thank all of you for your participation. For those of you that are part of our Sloan Symposium, we will convene at 4 o'clock, and Jordan and Jack are going to discuss biodiversity to start something. It's not open, I'm sorry. Huh? No, at the hotel. Okay, thank you very much.
Thank you.
You want to do the question real quickly? Okay. I don't. It's on the. One second before you leave, we need 3 minutes of your time. So we have these questions, and this question is not just about this session, but the whole day, including Mia's talk, the 2 technical sessions, and then this one. And you can read these questions and just get a real quick response, because we owe this to the Sloan Foundation for this. The session topics were relevant to the mission of these special sessions. Strongly agree or strongly disagree or somewhere in the middle. How many strongly agree? Okay. I got about 8 or 10. How many strongly disagree? Okay. How many are neutral? What? I don't know. I mean, I should have printed this out and handed it to you all to do. Okay. The presentation content and delivery was commensurate with their abstracts. Anybody have an opinion about that? You haven't read the abstracts. You haven't read the abstracts. The abstracts are on the memory stick. And okay, thank you. The special session was well organized, well executed, and punctual within the context of tonight's talk. Strongly agree? Thank you. Strongly disagree? Well, we know Jack was late, so.
I didn't say anything. He doesn't get on the punctual part.
Okay. The question and answer format during each session was constructive. We didn't really have a question and answer.
The guided question during this format.
Okay. I'm trying to find, I don't know how to use this computer. Whoops. That's one way to get done fast. Special question and answer format during each session was constructed. We didn't have one in each session, but in this session, strongly agree? Disagree? You disagree?
Yes.
Okay. The overarching mission of the special session was achieved. Well, no, I'll be the only one to answer that. And we can't answer it until the experts meet and try to respond to the questions that we got. The mission was to get questions from them. So we'll start our session with the experts offering an opinion about that. So thank you all very much. We really appreciate your participation.